Okay, so from product rule in 2.3, we have quotient rule 2.4. Here's a nice new disaster for you. We have in one notation and the other, so let's work through it. Quotient rule is for when you have two functions divided by one another. And we did that in product rule. We just set the denominator exponent to a -1, and we did product rule. You have a quiz on that tomorrow. Quotient rule gives us another option. So the quotient rule is if we have two polynomials or two functions divided by each other, then the derivative of that polynomial, h prime, is going to be this. The best way to remember this is you just find the derivative of the top times the bottom minus the derivative of the bottom times the top. So you just start with the derivative of the top. Derivative of the top times the bottom minus derivative of the bottom times the top. Divided by the denominator squared. That's it. Okay? Could get messy because there's a lot of functions, a lot of derivatives happening over here. But it's not that hard. Okay, in the Leibniz notation, same thing. If we have a function u and v and we want to find d over dx, the derivative, then we just find the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. That's it. So that's the formula for quotient rule. So let's take a look at how we can use it to find the derivative of h at x over here. So I'll use the regular notation, h prime, and I'm going to do the derivative of the top, 3, times the bottom, minus the derivative of the bottom times the top, all over the bottom squared. And that's my first step. Next, I got to clean up, so I'm going to distribute this inside here, collect my like terms at the top, and reorganize. So h prime at x is 3x squared plus 15 minus 6x squared plus 8x over x squared plus 5 squared. Cleanup time. 3x squared and negative 6x squared, that's negative 3x squared. 8x comes next, plus 15. And I have my derivative. I see a 3 and a 15. I'm taking a look over here. Maybe this is a multiple of 3. I can factor something out. Okay? Or maybe I can factor the top. Not really necessary right now, but you should train yourself to make sure that everything's fully factored. Can I get an 8 from a 3 and a 15? 15 and a 3, 9 and a 5. I cannot. It's not factorable. So this is my final answer. H prime at x. Okay, not too hard. This first step is your derivative step. That's it. The rest is just, grade 9, 10, 11 math, simplifying. Okay, notice when we did it using the product rule, there was a much more complicated process, right? Because we have to factor out that negative exponent. Okay, that's usually always going to happen when you're using a negative exponent like that. Okay, so this is probably easier in this scenario. Okay, let's take a look at the next one. We want to find the equation of the tangent. Guys, when you find the equation of the tangent, it's the same process. You need the equation of a line, y equals mx plus b, or in what it's point slope form, whatever you want. But the slope is going to be the first derivative at the x value that it's talking about. That's your slope. Then you need your point of tangency, wherever it's going to actually be tangent to that function, to plug it in to solve. So let's see what that means. Not too much space because we shouldn't need it. We want to find the derivative of y prime, or of y, which is y prime, the derivative of the top times the bottom, minus the derivative of the bottom times the top, over the bottom squared. I don't really have to simplify here because this is the derivative. It's an unsimplified version of the derivative. And because I'm plugging in 0, and 0's easy, I can use an unsimplified version of the derivative if I want. Okay? I could simplify and plug in. If that was a 5, I'd probably simplify because I don't want to multiply things by 5. But I'm going to plug in 0 already just to find my slope. That's going to be a 2 times 1 minus gone over 1. It's 2. Done. Okay, so I'm just plugging in 0 into all x's and figuring out what y prime is. This means that my slope is 2. I'm going to box that because it's a key point that I need to bring forward. Now I need my point of tangency. Okay, there seems to be a mistake alert here. We always make a mistake finding the point of tangency. You have to plug in the x value into the original function to find the y value, which creates where the point is that the tangent's going to exist. If it's saying at x equals 0, what's the y value? So we plug in 0 into here, and we get 0 over 1, which is 0. So my point of tangency is 0, 0. Well, it's going through the origin. The slope is 2. That's easy. My equation of the tangent is y equals 2x plus 0, or just 2x. Equation of the tangent. Again, need your point of tangency. You got to plug in that x value. If the question gives you a point, done. But if it gives you an x value, which most of the time it will, you got to find the y value, create your point of tangency, and find your y-intercept using that. Okay? We just fluked it over here that the y-intercept is 0, so we jump into our answer. Okay, last one. We want to find the coordinates of each point on the graph for this function where the tangent is horizontal. Got to find the derivative, which is the slope. I got to set it equal to 0 because I got to find out when the slope is 0 and then solve for x. So let's go. F prime is the derivative of the top times the bottom. You want to change it into rational exponents in the first step. I would recommend it, but I just wanted you to match it. Minus the derivative of the bottom Okay, just a quick recall here. Root x is x to the 1 over 2, and the derivative of that's going to be 1 over 2x to the negative 1 over 2. Okay. I've done the derivative of root x so many times, I generally just skip into the answer because I know the derivative of root x. Do it 10 times, and you're going to know it too. And this I'm going to multiply by the top and divide this all by the bottom squared, which yes, I know is just x, but let's leave it so we can visualize it. The derivative of the top times the bottom, the derivative of the bottom times the top. Let's start simplifying. 2 root x minus, what do I do here? This is going to be at the bottom of this entire fraction. So this is actually going to be 2x plus 8 at the top because both of these things are going to be the denominator. So this actually looks like 2x plus 8 over 2 root x. We'll take that in for a sec. Okay, so the 2 is a denominator. This negative exponent tells me that that root x is a denominator, so 2 root x is the bottom. And this is just multiplied by the 1 up top, so it sits up top. So it's a big move right there. This is all over x. 2, 2, and 8 can reduce into an x plus 4 over root x. So I'll show that step. Remember, a lot of times in calculus you want to show more steps because there's so much complication and so much miscommunication that you can do with yourself. I actually just noticed this too, so I'm going to take out, do I need to? Yeah, let's factor it out. Sometimes you're bored and you want to do some stuff that you don't need to do, all in good fun. Okay, so I took out a 2 from everything over here, from everything. You can't just divide by 2, right? I have to factor out a 2. I could set this to 0 already. I mean, you want to simplify it first? Let's simplify it because we got to simplify it. Yeah.
You can't set it to 0.
Why?
It's overhead.
So I can set equal to 0, multiply by x, 0, divide by 2, 0, and then solve. Nothing's undefined. I'm not setting x equal to 0. I'm setting y equal to 0.
Oh, my bad.
Okay, so let's set it equal to 0 because we're going to have to do the simplification anyways. 0 equals 2 root x minus x plus 4 over root x over x. Right? A bit of a disaster, but no problem. Look. Get rid of that x. 0. That's allowed. Divide by 2. 0. That's allowed. So right now I'm at 0 equals root x minus x plus 4 over root x. This is where I'm at. Do some stuff. You got to solve for x. So I'm going to actually do this division. So this is going to be 0 equals x minus x plus 4 all over root x. Common denominator. I'm multiplying that by root x. Give me an x. I see that x minus x. I'm very excited. 0 equals x minus x is 0. Negative 4 over root x. Okay, now what? I guess I can rationalize root x over root x. 0 equals 4 root x over x. This is just going to be 0.
Sorry, I think before you might have done something, because when I was solving for it, I got something different. Like, because I think it might have been back in the factoring. I don't know, because I
Here?
Because I did it slightly different. I got a different outcome. I don't know where. I think maybe. Oh, you factored. Okay, you factored out. You know how it's 2x plus 8 over 2x. You factored out a 1, thinking it was a 2.
What are you talking about?
Because it's like, okay, on the right side, up, there. 2 plus 8 over 2.
Yeah.
You factored out a 2 when that would cancel out. Or didn't you? Yeah.
Yo, it's a 2 over 2.
Yeah, you factored out a
Thank
1,
you, sir.
it was a 2.
So this becomes a 2 over 2, which is actually, I could have just canceled it. So let's do this. Do 2, and that cancels, and we're here. So the only difference is this is a 2. Should be.
That changes it. So the x is not cancel out.
Yeah, so this is going to be a 2x. So it's going to be an x minus 4. And then from here, I can just multiply the root x up here. Gone. Bring the 4 over. 4 equals x. Is that what you got?
Yep.
Got a little lost, made a mistake, went back and fixed it. I don't even know what this x equals 4 means. Read the question again. Determine the coordinates of each point on the graph where this is horizontal. Okay, we set it equal to 0. We got one answer because this is kind of linear, x minus 4. If you have a quadratic, you might get multiple answers. If you have a cubic, you might get 3 answers. That's eventually where we're going. So right now we only have one answer. So what's the point? Where's horizontal?
8. 4, 8.
How do you know?
That plugs into the original.
Find f at 4. F at 4 equals 8 plus 8 is 16 over 2. So f at 4 is 8. So my answer is 4, 8. At 4, 8, the tangent is horizontal.